down on 3D printers. And for those of you that don't know, we did have a failure of our server for the D-Star stack about a month ago. And Carter and a couple of folks worked painstakingly, mostly Carter, to get that thing back up and running. And it's running like a champ. So thank you, Carter. He does a lot of stuff behind the scenes that nobody sees. Like, he's the one who provides our internet. Shoots the internet up via microwave from their house. That's what gives us our internet for D-Star and DMR on the mountain. Anytime there's a problem, always ready, willing, and able to go up and help us troubleshoot and get it working. So thank you for that. Just so everybody knows who Mr. Behind the Scenes is, take it away.
Thank you. Like you said, my name is Carter, KN4DLI. Nice to meet you all. I'm sure I know pretty much everyone in here at this point. 3D printing. 3D printing, that's the thing we're doing tonight, right? I had a live demo that has failed horrifically, but I've got some other props here that I'll pass around here in a little bit as we get rolling. So 3D printing is basically just, it's a very encompassing word. It is the entirety of the additive manufacturing space. It's pretty popular now, and you can do a whole lot of stuff with it. So I'm just going to start down the list and just hit different technologies, and then kind of have a bit of a Q&A towards the end. So for starters, one of the first types of 3D printing technologies around was actually liquid resin based. And this is still a very, very highly popular method, especially in the industrial space. And it goes everything from high-end SLA laser-based systems to a LCD in a box that you can buy for $100. And what it is, the difference is one is stereolithography. So it uses a set of galvanometers underneath a vat of liquid resin. And that liquid resin is sensitive to UV light, right? So you expose it basically to that UV light and it instantly hardens. I mean, within 2 seconds, it's completely solid. Same thing for the DLP/LCD or digital light processing methodology, but it uses a slightly less controlled, more inaccurate methodology. Basically, you've got an LCD display, and you blast that UV light through it while turning on sections of the display and allowing light to pass. So very, very similar technologies, but pretty different. So there's the innards of an SLA type system. As you can see, you've got a scanning XY type setup. It's actually the same thing they use at big music festivals and raves to shoot lasers into the air. Same exact principle, just a lot more focused and narrow. This particular method looks like that. And there you go, I'll let it run for just a second. But it's hard to tell because of the camera, but you can see it kind of running around the base of the object. It never stops, right? So it literally is just pulling this object up out of a vat. It's like magic. So the pros here, just like the other method, it can do make completely solid models. So unlike these type printers where typically it's hollow models, you can make completely solid objects. The really special thing about these though is you get things like flame retardancy. You can have biocompatible resins where you can make implants and other really, really niche type things. You can also have ESD resistant. So unlike a normal plastic, like a PVC, that has a lot of static buildup on it, you can have completely ESD resistant materials. Great for, again, specialty things, aerospace, that kind of sector. The other benefit to having that is it's completely solid, and you can get transparent resins, and you can even polish them down and you can make lenses out of them. So if you have a lens design that you want to try, you can probably make it on an SLA printer and give it a shot first. Downside is it's really expensive. The Formlabs Form 3 printer starts at about $2,500. So it's a slightly less accessible option for the home user, great for small commercial stuff. And it's also very messy. Same for the DLP method. It's very, very, very messy. It requires having a normal amount of isopropyl alcohol on standby. Here's the LCD method. Again, uses an LCD display, and it's a monochrome display. So you just simply open up the pixels, and voila, you then have your exposed layer. Now, the LCD method is a little different. It can expose the entire volume of the build area in one go. So as it makes a layer, it makes the entire layer instantly, as opposed to the SLA where it has to trace the object, or one of these type of printers where it has to place the object. These are very good for small batch type production, where you can make a ton of little tiny items very, very, very quickly. It's also a lot more affordable. The Elegoo Mars 6K starts at $250, so very, very accessible to the average person. Again, though, resin is nasty and not good, and you have to wear all sorts of gloves and respirator, and it's just not good. Which is where the popularity of these come in. We'll get to that in just a second. This is another industrial. This one's very industrial. This is how you do metal 3D printing. So basically you have SLS and SLM. Currently the best systems on the market are the Formlabs systems. What they do is they use the heat from a laser, which much like an SLA printer is driven by one of those galvanometers. It uses the heat off the laser to literally bond fine metal particles or plastic particles together to make parts of comparable quality to, say, an injection molded part. Basically the same as the SLA, but inverted. And so it actually drops the item down into the volume of space as you go. This one, though, can also sort of defy gravity because the parts that you print have an encapsulation of powder around them. So you can print them completely. You can print things that are unnatural overhangs and things that are unprintable on a printer like this or an SLA. Here's what that looks like. And that's, if I'm not mistaken, is nylon powder. But you can do things in aluminum. Yeah, there you go. Nylon, TPU plastic, iron alloys, aluminum alloys, titanium, copper, nickel, cobalt, to name a few. And this is really good for functional parts to go in, so say for instance, some of the Formula One race car guys have these. They come up with these wild designs on the computer that can really only be manufactured in theory, and these things can make it. They might not have the strength of a normal machined metal part, but they're pretty dang close and good validated test. They're about $30,000 though, so most people don't have that. So really it's limited to the industrial space. And then on the exact polar opposite end of the spectrum, you have material deposition 3D printing. Things like the Creality Ender 3. I think this machine was like $100 at MicroCenter. And I've just modified it with open source parts at this point. For a more out-of-the-box type use, there's a company called Bamboo Labs that makes a really fantastic, just give it a file, click print, it goes kind of system. A little bit more pricey, but completely functional out of the box. I opted for this route because I'm broke and because I had enough willpower to tinker with it. That's about the extent of why I'm using that one, but at this point it performs almost identical to one of the nicer machines. So it is possible, though, to have a machine that prints and makes parts for pretty inexpensive. That's why these have become richly scattered across the world, and you can buy them on Amazon for anything from $50 for a little teensy tiny one, all the way up to something like that. So FDM is the technology here, or fused deposition modeling. I've also heard it called filament deposition modeling or fused filament fabrication. These are completely different systems. They use a XYZ based gantry system. So it's got a print head that is literally a heated tube. And you take a piece of this plastic filament and you just shove it through there. And it compresses and is extruded into a line. And you can move this entire system left and right, forward and backward, and it will produce a object layer by layer. You can see the layer lines though. Here you can just kind of hear it. So it's far less accurate, and I'll start passing these around in a minute. It's far less accurate, but for practical use, it's about as good as you get. So here's what that kind of looks like. So as I said, you have a spool of material, plastic in this case. I've also seen it done with chocolate and other things. Yeah, there's like kits that'll convert these, $100 printers to print in edible chocolate. And you can have all sorts of crazy stuff right there on your desk. It's insane. But all the systems work exactly the same. You have a heated extrusion head, right, and a nozzle that brings this material down to a fine point. This one's bringing it down to about a half of a millimeter in size per line. And you just keep layering them up into a mesh on top of themselves. And because it's hot, they bond. They literally melt from one layer into the next. And it gives you a pretty robust, solid part. I mean, I can just, it's okay. It's a fairly solid part. It's not going to withstand running a car over it, obviously. But it gets the job done for most things, just to validate a design. Usually, like if I have a design I want to take into a metal type application, first step is to make it in plastic with one of these. Here, pass those around. And we'll send those around too. I'll send those around. Yes. Here we go. Be gentle with that one. So the Eiffel Tower and the hexagon silencer are actually products of the LCD method. So those were printed in resin, they're completely solid, but especially with the Eiffel Tower that's going to come around, you can see it. It's able to make these very steep 45, almost 90-degree overhangs in the air. And they have exceptional resolution, down to like 25 microns of resolution. So it's very highly detailed as opposed to the other stuff. More messy, harder to work with, but better product. Anyway, FDM, so that's pretty much it. You just have melted plastic and you just drag it along. There's what it looks like kind of as an animation there. So you can see the gray. The problem with this is you have to have things to support your model in the air. So we also have to add these support structures to hold against gravity, which is an advantage of some of the SLA, SLS type systems. Yep, I'll give you guys a minute to pass those around.
Okay.
And how long does it take to print, so it's like this box that you just threw on the floor?
That was like 7-8 hours.
7 or 8 hours?
Yeah, the base was probably about 12.
7 to 8 hours for 1 box.
Yeah.
Oh, was it 2 old ways?
Yeah.
How do you tell it what to do?
I'll get to that.
Okay.
Yeah, we're getting there.
So you don't have to wait 12 hours. You can get somebody to make it for you,
See the
And he
And-
wait 12 hours.
but they charge a lot of money. Prototyping is expensive.
Yes.
So the clear ones are usually done on a laser, and they make like a 2D model of it, and they make the sides and the bottom and the top on a laser, chop out all the holes, and then just kind of fit them together. That's usually how that
We've
gets
actually
done.
got a printer
You can
from
print
the Radio
this.
Club.
You can print cases.
We just haven't done a unit
off
on
of
it
this
yet.
machine, but they're going to look like what you have in your hand.
Yeah, that's what.
So they do work, and there's a functional model. That's actually a Wi-Fi mesh
We
radio.
probably got 30 or 40 of them floating around.
Bottom
the school.
covers were printed.
I don't know
whole
exactly
entire
how
top
many,
model
but
was
they're
printed.
all spread
You
around
can't
the
see
space.
it, but I mean, it's even seamed together in the middle. It was 1, 2, 3, it was 4 different prints on this. Again, probably 12 hours, but that's a really robust item. And you guys have to do.
I mean, do you have to be with it for 12 hours?
No. Lord, no.
You can-
Usually my MO is I'll get it started, and if everything goes good on the first layer or two, I can usually walk away And it's just it's a practice thing. After you've done it a couple times, you can get a sense of what's going to fail horrifically on the first try, what will go fire. And that's why I've got a camera on there so that I can watch it from my phone and get alerts. So no, you do not have to sit with it for 12 hours.
They were selling these like for $99.
Yeah.
A lot of people don't.
Yeah. That's literally what that is.
What, how much would it cost and how much knowledge would you have to make it in one place and work like that?
It depends. So the ones out of the box do function. They work and they print objects totally fine. After about 6 months of using them, they start to wear down a little bit and you start having to have things replaced. Most of the stuff on this printer is because I wanted higher accuracy, I wanted to push the boundaries, and like I wanted to print in other materials like rubber, which I forgot all the rubber models. But that's what you're looking at. Not so much a, not so much a.
You won't go into detail on that. That's an entire electronic design project. So,
Those were printed, and then I ran the other printed part down into it and worked it a couple times to get the threads loose. I really should have opened the threads up a little in the model, but yeah, all of that was printed as is. That was on the resin printers.
because there's not any better ways to custom design certain product that doesn't exist, so it should he designed the enclosure.
All right.
To
So we all seen some of the
match what he needed. Kurt, when you get finished, they're asking about those enclosures. When you finish everything, kind of tie it together by, here's a practical application of something that didn't exist and it needed an enclosure, I
Why
created
not
it.
walking around?
Yeah, do that at the end.
Yeah, so those were printed on that machine. The difference is the bottom side, the glassy looking side, was printed when I had the shadow removed glass. So it's printed onto a piece of silicate glass, and that's why it looks so shiny. The actual like printer and everything, no, that's straight off the machine, no post-processor.
3 seconds.
Tell us,
Yeah.
you got more?
Yeah, I've got more. Sorry, I took a break there to pass stuff around.
GE master plate.
So.
Click and go.
Anyway, the box that's going around there, a lot of this is heavily pulled together by the fact that that item did not exist previously. That is a radio, it's a Wi-Fi mesh radio, and it's in a box with a battery, and none of that item was here 6 months ago. The entire purpose of that was to be a tactical data link radio for me and my airsoft buddies, so that we can do situational awareness and send pictures and drone video feeds back and forth to each other. And it's literally an off-the-shelf radio, stripped down, put in a box with a couple batteries and a switch. So that's a very practical application, and I've got 4 of those. Took a while to print them, but they've been field tested and everything, and they work great.
It's like a Raspberry Pi, I think you could
Yeah.
build a case for that.
Yep, exactly. Anyway, and on a totally unrelated note, you can also print houses. So that one's printing a fast cure concrete mix. So within 5 minutes, that concrete sets, and by that point, you're already on the other side of the structure coming back, and whenever you get back to the next point of layer, it's solid. And this is pretty tried and true, and there's a couple companies that are doing it commercially, making actual code inspected, proper buildings that you can live in. So, yeah, they're huge printers. I mean, like, 100 foot by 100 foot instead of 100 millimeter by 100 millimeter. But same exact principle, right? You're just laying layers of whatever, and they adhere to each other. Pretty much if you can do that, it's a 3D printer. Anyway, so the pros of FDM, right? Super simple to learn. Fairly easy to maintain and operate the printers. Parts are really, really cheap. I think the roll of plastic was like 20 bucks. So you do the math, and each one of these, I think that whole practical case build was maybe 200 grams of plastic. So you get a good bit for your money off of the material costs. The printers are expensive, but I mean, like I said, $20 on Amazon for a roll of filament that shows up next day, and you can just keep it going. You can get them in any color, material that you want. Rubber is a thing. So due to material design though, and thermal expansion, and the fact that you're dealing with really high heats of say 200 degrees Celsius, things tend to expand and contract, and the tolerances are a little bit farther off. So when designing for these type machines, you have to just be pretty intentional with the design and acknowledge the fact that your constraints will be changing when they hit the printer. Parts are not necessarily as strong as some of the other technologies, and a bunch of the materials such as PLA are fairly sensitive to UV exposure and water intrusion, that kind of thing. So it's a limited technology, but it's definitely got its place for functional parts. Edith actually asked me earlier, I think, how do you get it to be a part? How do you run the machine? How do you tell it what to do? So that's basically your workflow, right? So you've got a 3D object, you turn it into a bunch of triangles, send it to another piece of software to slice it up into layers, put it on your printer, the printer makes it. That's the high-level overview. So step one, you gotta have a file to print. And there's a whole boatload of different softwares to do that. Tinkercad is probably the easiest to learn and just play with for simple designs. Google SketchUp, also pretty easy to learn. I'd say a little bit less accurate for printing, but it works. Blender is awesome if you're wanting to make abstract art, shapes that really are not mechanical parts to be assembled, right? Say you want to make a sculpture. That's where that comes in. OpenSCAD, also super powerful, but everything is a text file. So there's no graphical interface. You're writing code to generate the model. Onshape is all web browser based, and Fusion 360 is my personal choice. They offer it for free to hobbyists, and it's basically AutoCAD in 3D space. And it's very, very tailored towards doing exactly what we're doing here. So yeah, you can design it. There's what it looks like in Tinkercad. You make a square, draw it out, and add your features. And yeah, there's also the internet. So screw all that. You can just download it.
Somebody else does it.
Yeah, exactly. Somebody like me makes a part, says, oh, okay, I'll go share that. And now it's on the internet, anybody can grab it. So there's some other services out there. Thingiverse is a very popular one. Printables, My Mini Factory, Thangs. Yankee is a search engine for all of the above. And yeah, look, type in UV5R. Oh, I've got a whole slideshow of things. I've got a whole slide full of links for you to take a picture of.
Okay, perfect. 'Cause
Yes.
you read my mind.
So there's a Yeti search for UV5R, and you got everything from the exoskeletons. Shoot, there's a full one-to-one model of someone that 3D scanned the mouth thing. You know, you got belt clips, whatever, and that's just off one keyword. There's infinite things to be had. So there's a clip for the Balfang. And there's the exoskeleton. Some places and some designers want you to pay for things. That's just the world that we live in now. So like they want $10 for that file, and you can print it as many times as you like. So yeah, exactly. You can buy the radio for $10. It's not even worth it. Anyway, so after you've got a file in hand, this is my demo file. You then can convert it with whatever software you designed it in, or if you get it off the internet, it comes pre-exported into a file full of literally just triangles. And because everything on the printer is in, Cartesian space, you got to be able to figure out how to make that object, right? You can't just say, put a circle here. You have to say, okay, draw a bunch of triangles, and they'll all come together to make a circle. So it's kind of the way that the next step is able to understand the model. And there's various different methods for doing this. I choose STL files. They're not super accurate, but they're the easiest to work with. So then we get to the thing called slicers. So basically, the printers are actually stupid, like horrifically, terribly stupid. They have no idea what they're doing at any given time. So you have to feed it commands one line at a time. If any of you are familiar with the machining space, G-code is the language that these machines speak. They speak a language of go from this point, literally go 30 millimeters to the left. And while you're doing that, spit some plastic out. And so the files that these read are not hardly human readable. They are, but you end up with, say, 100,000 lines of instructions. So to eliminate the human step, slicers are the magical software that makes these printers easy to use. So right there is my imported model from my CAD software, or Fusion 360, or the internet, or wherever I got it. And this is free software, it's Ultimaker Cura. And basically what you do is you give it your file, and you give it some parameters. So up here, I'm saying make it 10% solid. Make sure that you add some supports to hold it up in the air, and make it stick to the bed with a set of rules that I've given it. Pretty easy to use. You can just drag your model around on the page, and it'll put it physically on the bed wherever you choose it to have it. You then hit the slice button, and after giving it some information, which none of this really has to be changed, this is my personal preference, right? So after experimenting with this particular printer for 3 years, I've just come up with a good handful of general rules that work for this printer for what I'm doing. So I run the bed, 75 Celsius and the nozzle at 235 for this particular roll of filament. It changes with every material batch. It's just trial and error. And then you can set some things like how fast do you want it to move, how thick do you want the layers. So it's printing 0.2 millimeters tall on each layer. How many outside perimeter walls do you want? That affects the solidity of, how rigid the item is at the end. So all of these are pretty general settings, and the slicers are available for any of those technologies that I was listing out earlier. So they're resin-specific slicers, SLS, SLA slicers, and then a whole slew of FDM-based slicers. Cura I've found to be the best, most reliable in my opinion. Other manufacturers have their own, whatever. It's personal preference. So then it spits you out even an estimate of how long it's going to take, how much material it's going to use, and how much it's going to cost you. So I've got a mount plate about that big, and it cost me 62 cents to make it. Literally the power to run the printer probably cost me more than the material. So it's very, very economic. And there's what the sliced file looks like. So you can see it added some texture. There's some holes around the actual mount holes. You can see it's added some extra blue around the outside to make it stick better. And you can even see the little lines where it's going to travel between different spaces in between its process. That's what the inside looks like on this particular type of infill. There's several algorithms of what the inside of these models can look like. But all the items that you guys passed around earlier, they have that same kind of design in them. Some can be a three-dimensional square turned on its head. Some like this is called gyroid, and it's just, sine waves stacked on each other with a little bit of a phase offset every time. So that's what actually gives the item some structure and solidity. So then you get your G-code file, and you can come over to your printer. Mine is set up with a web interface, and you load it and hit print. And from there, more or less, you can walk away. I usually eyeball mine to make sure that nothing's going to go sideways, because if it will, it's going to do it probably in the first couple layers. And from there, yeah, you can walk off and set a timer for whenever your slicer said it was going to be ready. And come back, and it's like having a microwave, just ding, ready. So, yep, hit click print, and you wait. And there, the printer firmware said it was going to be 2 hours and 45 minutes, and that's not far off of what the slicer said. So there's a print on this machine. I want to say that was over the course of like 6 hours, but it's a pen holder. And you can just see it layer by layer.
It's like glass that prints on.
Yeah. Yeah. So one of these, the bottom of the surface was completely solid, or completely smooth, and it's because of the glass. There's all different types of materials that you can use. I was using glass for a while. Now I use like coated, textured sandpaper, almost like surface. And that's what most of the printers come with, like on board. And I've just found that this one sticks better and gives me a prettier looking surface. So.
I was wondering if it had to be like a non-stick. I mean,
No, quite the opposite.
Chisel it off of there, or?
Quite the opposite, actually.
Yeah,
So, on the glass, I liked it because the glass, when it's hot, is actually very, very sticky to the plastic. I mean, to the point where you can literally pick the machine up by the part. And that's great, because if not, the plastic will get warm around the edges, start to lift up, bow, you can have a failed print or just a bad looking product. And then actually on the glass,
So
when
is
it
the
cools
paper
down-
heated? You said it's
Yes.
glass, but
Yes.
it's actually heated itself.
Yes, yeah, there's a heater element underneath there. So that bed was at about 80 Celsius. And the top, the molten plastic was at about 230 Celsius. So it's just enough to make the plastic kind of tacky. And again, there's a fine balance there. But what I really liked about the glass is because of the thermal expansion and the cooling properties of the plastic, you can actually, most of the time, once it gets below like 35, 40 Celsius, you can literally hear it audibly crack and it'll separate itself and you can just literally walk over it and take it right off. And it's a polar opposite where when it's hot, you can pick the machine up by the part. When it's cold, you can just slide it off the bed. It is wild. And I have slightly different issues with this bed, but this one also comes off, and like an ice tray, you can just bend it and get it to snap off. Sometimes a chisel is required. I've had more than one of those. And that usually is not fun or safe, because you end up chiseling in your hand. Anyway, that's a whole different topic. So I said there was a bunch of links. That's pretty much everything that's been in here. Printers, design software, slicers, and a whole slew of other resources just to get rolling.
Alien technology.
Yes. I mean, they've got printers going up on the space station,
Oh, I'm sure.
printing in microgravity.
Carter,
So
could
literally,
you-
everything.
Could you post that to the group site?
Yes, yes, I
So,
will.
It was
so the
done-
links are hot.
Shoot.
Tons of people. in that
Yeah,
building.
yeah. There was a handful of different people along the way that have all chipped in.
So who all in here has a 3D printer?
Oh, yeah, no.
It's kind of curious.
Yeah,
For
yeah.
some-
I have that same exact one.
Next question, who in here wants a 3D printer?
Yeah, so for someone, a beginner, like myself, that does not have.
You just
one,
need a
that
friend
knows
with a
very
3D
little about it,
printer.
what would you recommend for someone that, in my situation?
Are you willing to tinker with it?
Okay.
I'd go with
That's
it.
why I want it.
I would go with one of the Creality Ender 3s, just like this.
And that's the, I
Yeah,
saw the ones last year at Micro Center during the
Yeah.
Black Friday, and I wanted it.
that is literally what you're
Something
looking
got
at.
in my way and I didn't get it, but that was actually on sale during that Black Friday thing.
Yeah, I think that's where this one, I think this one was a Black Friday deal there too.
What if you added,
Actually, that one made the long trip from China.
There you go.
what all have you added to this?
Shoot. So everything that's not solid black, so all the gray parts, those are added. Most of them, the printer printed for itself, so like these little covers, they keep dust and stuff out of the wheels, those were printed. There's other covers on there, filament sensor, the whole extruder head has been changed and is no longer the factory. The bed has been changed, the wheels on the bed have been changed, the camera. There's a mount over here that's been changed. And there's actually a Raspberry Pi on the side that lets it be internet controlled. And it actually uses image recognition on the camera to tell me if it looks like a part has failed, and it will alert me. Oh, and I added another motor on this side for the Z-axis. So that is not a stock Ender 3 by any chance. It's like cars.
Mine came with motors on both sides, it's an Ender.
Yeah.
It's got motors, you know, so it stays nice and.
Yes, yeah, because I changed out the extruder head.
Yeah.
And I moved all the things that were over here, now live over here. So it gained about 2 times its weight. And if you don't have another one on the other side, it'll sew. Yeah. So,
I don't think I had $200 in mine,
no.
so, and then just buy plastic and start goofing around.
Yeah. There was a whole, I mean, usually, yeah, the ARC 3D printing subreddit. There's several YouTubers. Maker's Muse is one that I follow. Those are some pretty good resources. The ARC 3D printing link is literally to their getting started page for beginners. And there's a whole slew of information for everything you could ever want to know. Machine suggestions, whatever. Those guys can answer any questions better than I can for the most part.
If you just take a standard thing I've you'd be surprised at all the different models for anything that you ever want. You want the door handle to be there, you want a mic holder, it's there, you want a modeled radio, it's there. I mean, there's.
Yeah, here.
Parts to print for making.
I was about to pull it up. but I don't have it.
3D birthday cake.
I can give you energy.
Oh, I have a birthday coming up, so that's on my short list.
I printed Link, all the pieces for a Link dipole. I printed these boxes for MMDVM or Pi Stars. Rails for your 891, I think I still have them, I give you those. The case for my 705.
Yeah, that case over there, is that something? that-
No, oh, the black, yeah, not the one John's holding.
Oh, well, I was looking at, I was thinking of John Holden.
Yeah, he,
Not that one, okay.
Anyway, so there you go. That is 3D printing. And like I said, there's my email address if anybody wants to know any more. Shoot me a link, and
I wanna know
answer any
more.
questions. Yeah, and I'll post all this on the group's IO and probably that list separately. So yeah.
A big thing for that.
Realistically, 200 millimeters, so the width of the
Yeah, the
bed,
side
the
of
length
it.
of the bed,
Okay.
and it'll go up to about that tall. So it's about a 200 millimeter.
But they're ones that can print.
Yeah, they make them in every shape, size, and fashion.
We have one at work that does 36 by 36 by
Yeah.
like 36. Just trying to see.
If I can find somebody who's got a big 3D printer, I can print it out of 95.
Probably
find those files.
Oh, it's FDMs.
Yeah.
We've got 4 FDMs and then so.
Where do you want?
Yeah.
It's supposed to make sound for
But the price goes up exponentially.
Oh, yes.
Yes.
It's dark in there.
The last printer I bought for work was $170,000.
Oh my gosh.
What's that?
And that saves them a lot of money because we have to outsource a prototype door for $6,000 to print it. We can print it ourselves in a day and a half, and it'll cost us about, no, it'll probably cost us about $60 to $70 worth of material. They charge you $6,000.
Okay, what's the interface between the laptop and the printer?
So what it is over Ethernet, and it's got a web server. However, out of the box, you literally just load it on your SD card, top it in the front, which will run the front. It's got access to the link. Yeah, the bottom firmware, you just put it on like your SD card, put it in the front, and then you can scroll through and hit print.
I had a question. I've got that same exact printer. Your print settings are much hotter than what comes as default in what I have, because mine is like 200 degrees and 50 or 60 on the bed. So do those work better that you found? Because if so, I'm going to try process. It's PLA.
Yeah, that's the difference. This is,
Oh, you're,
yeah,
Carter,
oh, I didn't see it was.
Carter,
yeah.
what speed,
Okay.
what,
So that gives you better.
firmware are you using, and how fast
But I
is it
thought you
going?
had to have that in an enclosure for DTG.
ABS, absolutely.
Yeah.
PETG, it depends kind of on your results. I run a hotter bed temp, so it kind of naturally keeps the air around warmer.
Roland, are you gonna come and take
I
this
have a
out?
little bit happening.
But you need to upgrade.
That also lowers like.
Definitely, and I
That
don't know.
doesn't put out that bad chemicals like.
So you're a
ABS does.
techno or a general? Okay, right, because we're doing tech this Saturday, and then we've got one. So it's like every other month,
They really want you to.
basically the first Saturday of the month. So we'd love to help you on your journey.
And resin, absolutely.
So why don't you use that material over PLA?
Honestly, those are really.
For what?
So were there people who do, like welding shops, you can get them to go do something, were there people who